And again, welcome to today's webinar, On-Demand Video Streaming Using Amazon CloudFront. Our presenter is Nihar Bahani, Senior Product Manager with Amazon CloudFront. Nihar, you have the floor.
Thank you, Anna. Hello, everyone. Thank you for attending today's webinar. And so I'm a product manager with Amazon CloudFront, and we'll talk about on-demand video streaming, specifically adaptive bitrate streaming, using Amazon Web Services. So let's look at the agenda. What I'll be doing is a couple of things. First, I've got about 15 or 20 slides, so walk you through some slides and some of the details around the components of a media streaming stack. So we won't just be talking about delivering your video, but we'll be talking sort of an end-to-end workflow, starting with ingesting your video into the cloud and then processing it, and then storing it, and then finally delivering it. We'll also see how rapid increase in viewership using the variety of devices that are available today, how that has created a new set of publishers like yourselves have to deal with, and how the AWS Cloud can help there. And then the second part of the presentation, we'll really be doing a demo to see the AWS console in action and creating resources with different AWS services, such as Amazon S3, which is our storage service, Amazon Elastic Transcoder, which is our transcoding service, and then also Amazon CloudFront, which is our content delivery service, and seeing how we can tie these resources together to do an end-to-end video streaming delivery stack. So let's talk about the components of a media streaming stack first. We'll start with ingest. So typically, media companies have large on-premise storage, and it's usually on-premise, or it's been at least the case because of primarily security reasons. Companies we see have tiered storage solutions, everything from working storage solutions like EditBase, where they need high-speed connectivity or fiber channel connectivity, to local SAN storage, maybe even some bigger storage for storing your catalog, and even some offline or off-site storage for archival purposes. But what we're seeing and hearing from media companies and content owners is that they're having a hard time keeping up with all of their storage requirements. So a couple of reasons for that. One, the content is getting increasingly bigger. The file sizes are getting increasingly bigger. We're moving from standard definition to high definition to 3D to 4K, and it's just going to continue to grow. And then also, the other reason is content is coming from a variety of different sources. There's a lot of network content from cable and satellite providers. There's a ton of UGC content or user-generated content on the web today. There's content from live events, sporting events, and so forth. So both of these trends, in terms of the content size getting bigger and the variety of content increasing, it's really creating a problem for a lot of media companies in being able to manage their storage. So, with these challenges, media companies are starting to think about moving up a lot of their storage into a cloud environment. And there are a number of methods that you can use to do that. You can just sort of the traditional pushing it over the wire, pushing it over the internet. There are also accelerated software solutions that are available from companies that are on the AWS partner program, so companies like Aspera or Signient and others. There's always a direct connect option or a direct fiber connection with the AWS cloud, and there is also the old school shipping hard drives to your cloud provider. So lots of options available there today in terms of moving all of that content that you have into the cloud. And then, in terms of growing the size of content that's growing, and also the different types of content and different types of files, once the content is in the cloud, and you start processing that content, you got to start thinking about the different types of output formats to support the growing number of platforms, and all of the storage space that you'll need for storing and archiving all of that processed content, not just the raw content, but after you've processed it. There are different codecs, different container formats, different screen sizes, or different resolutions, plus all of that source content is still there that you need to store. So durability can also be a big issue. Once you have processed all of this content, you don't want to lose those files. And when you're doing storage on-site or on-premise, you have to think about making multiple copies of that content so that you don't lose that content. With the cloud storage solution, you will often get the benefit of multiple copies across different data centers, across different coasts, and maybe even across different continents. So, using a cloud storage service can provide you that high level of durability that your content would need. You also need to think about automation. A lot of large media content libraries, you need to manage and automate the processing of that content, sort of lifecycle management. You may want to have a policy that's based on how frequently your content is accessed. So let's say if a piece of video or a piece of content is not accessed for over 30 days, you may want to have a policy to automatically archive that into long-term storage to save on costs. The other thing you also want to make sure is you have compatibility with your existing solutions. So having a rich ecosystem of partner solutions is also an important consideration when you're thinking about moving your video content and processing that in a cloud environment. There's actually a virtuous cycle here. As the amount of content on that cloud increases, there are more of these ecosystem partners and partner solutions that become available. And when there's more partner solutions available, that also results in more content being uploaded and stored and processed in the cloud. So there's a virtuous cycle here as well. We've talked a little bit about processing your content when it's up on the cloud. That specifically means transcoding and transmuxing your content, so converting your input files into multiple output formats. Typically, your input files you'll have full resolution source files that may be mezzanine level files, which is basically a file that has a resolution at least as high or greater than your most demanding target output device. So once you get the files into the cloud, you'll need to transcode those or transmux those, meaning putting them into a different container format. And traditionally, we've seen companies and people have used protocols like RTMP or some of the other older protocols and proprietary protocols, but have run into issues with these protocols because those are not HTTP based. So those protocols wouldn't have an easy time getting through firewalls. Most of the newer delivery protocols such as HLS, HDS, Smooth, and other standards efforts like MPEG-Dash, all of these have the adaptive bitrate streaming protocol with the concept of segmentation. So segmenting your source level file into smaller chunks or segments at the appropriate bit rates and in multiple bit rates so that a client's player can adapt to the bandwidth that's available to it and fetch the appropriate bit rate chunk. So there's a couple of ways you can do the segmentation. You can do file level segmentation or virtual segmentation. With the file level segmentation, you're creating those chunks from the larger file in advance and then saving those chunks into your storage device. So this is especially helpful for popular content because once you've created those segments and stored them, you're now delivering that exact same content over and over. Virtual segmenting, on the other hand, is helpful for long tail content just because of the sheer number of permutations that you would need to do for content that's long tail and requested less frequently, but there's a large source collection of content. So there are some considerations there in terms of preparing your files and doing file-level segmenting versus virtual segmenting, and we'll talk about how you can do both of those with AWS. So let's talk a little bit about audio and video codecs. This is kind of a busy slide, and I'm not going to get into all the details here. But the idea behind codecs, so a codec is an acronym for compressor and decompressor. So when you're taking a source-level video or audio, you want to compress it so you can save space and make it easier to transmit over the network. So typically there are two kinds of codecs people use, lossy and lossless. Lossless means that you can compress the file down to file down some amount, and when you decompress it, you'll still have all of the information that was in the original source file. And then lossy, is a compression type where you do lose some of the information. So the quality is impacted a little bit in the lossy compression. So, typically you want to use lossy compression on the delivery side, and then lossless on anything prior to delivery, like when you're editing or capturing a video. And these days, we typically see H.264 for video and audio, and you see AAC, and oftentimes you'll find this in an MP4 container. So that's sort of the typical configuration for audio and video codecs that a lot of the media companies we see are sort of standardizing on. So anyways, just wanted to give you a high-level overview here without getting into a lot of details. Talk about file containers a little bit. This is a list of the traditional container formats. So you'll find most people are delivering video these days in the MP4 container, which sort of historically has its roots in QuickTime and Adobe Flash. So it's very pervasive in the market. You'll also see some things being delivered through formats like WebM and Matroska, the MKV file that you see, some of that still around. ASF is a Microsoft Advanced Streaming format, and it's a little bit of an older format that's used for Windows Media Technologies. AVI is another one from Microsoft. And then FLV is the Flash video container, which still remains popular due to some platforms still sticking with RTMP. A lot of it is due to legacy reasons. So this, this slide, the media delivery protocols, is actually a little bit more interesting. If you look at this, people are standardizing on H.264 with AAC and an MP4 container on the codecs and container side. But protocols is where really the sort of the interaction with your viewers comes in the method in which your content is delivered to those viewers. So this list starts with progressive download, which is what YouTube has used for a long time, although YouTube is starting to move to some of the adaptive bitrate protocols now. But progressive download is essentially where the user downloads the entire file from the server and plays it on the client. So, as you can imagine, the problem here is that if you don't have a server that has some sort of communication with the player, you can end up delivering the entire file, even though your users are only interested in viewing just a small portion of that file. So this ends up costing you a lot more in terms of bandwidth and just delivering the entire file. Pseudo streaming is HTTP based, but requires logic on both the player and the server. So this has its drawbacks as well. And then just for completeness, I've got radio streaming protocols such as Shoutcast and Icecast there, but these don't really work well with a lot of the CDN networks. The last bullet, however, on adaptive bitrate streaming is where we'll spend the bulk of our time today. So adaptive bitrate streaming is where you take your source file, transcode it into a number of bit rates, and then you end up with one resolution, for, say, your smaller devices like a phone-type screen, a bitrate with a higher resolution for your tablets, and then an even higher resolution for your PCs or your game machines or your TVs and so forth. But the idea is that you end up with multiple bitrates that are optimal for your target audience. And then once you have those bitrates available, there's also a file that's traditionally called the manifest file, which describes what those files are that are available and where the player can find those various chunks or segments of those files. So, you know, Microsoft Smooth Streaming is one of the flavors of adaptive bitrate streaming, and Amazon CloudFront, AWS's Content Delivery Network recently added support for smooth streaming. So we'll see that in the demo. Apple's HLS is a great protocol for the iOS devices and a lot of the newer Android devices. Adobe's HDS is traditionally used to reach Flash-based clients, so primarily PCs. Flash is not as pervasive with many of the other devices. And then MPEG-Dash is an industry standard that's emerging, that's starting to sort of catch on recently. And more tool providers and content owners are starting to deliver their content in this format. But at this point, a lot of what we see is HLS, and HLS appears to be the leader in the industry in terms of protocols. But HDS, Smooth, and Dash also have and are gaining popularity. So how do you actually generate a stream? And there are a couple of options here. You can pre-encode the files directly from your storage medium, or you can use streaming servers and do the stream generation in real time using transcoding and transmuxing. So, we talked a little bit about this, but pre-encoding the files, that is suitable for popular content because you're encoding it once, and you're delivering the same content over and over to your users. And it just has the advantage of less moving parts because once you've done the encoding, those files are there in your storage medium. And you can store them in a location like in an Amazon S3 bucket, and then your player can reference the manifest and the chunks directly, and it's just hugely scalable that way. It's a pretty straightforward solution. It doesn't require you using a media server like the Adobe Media Server or the Microsoft IIS server or anything like that. But for real-time transcoding, you do need to use a media server in your workflow so that as your clients request a particular file, that file would not be encoded in advance, so the request is then sent by the edge server to your media server, and that media server in real time will process that file and create those chunks and then deliver them back to the edge server for caching and forwarding them on to the client. So, more moving parts here, as you can already tell. And, while this is helpful in scenarios like live video streaming and others, it does require you to manage and scale sort of this architecture of running a media server and making sure that, things are performing and are available in the way you need them to be. Just a quick comment here in terms of media players and devices. This is really where your viewers, your end users are interacting with your content. So super important, but at the same time also confusing just because of the variety of options that are available in terms of different devices and different types of players that are available on those devices. So it's a huge challenge, for you to figure out which of those players and devices you need to be supporting, what are the optimal protocols and formats, and you really want to maximize the reach for your content. So it's a question of complexity versus reach, and this is something that And I'm not going to dive deeper into right now, but it's something you need to consider as you're thinking about your media workflow and sort of that end user experience. Content security. This is another topic that can often be complex to understand just because of the variety of options that are available. Again, you see on this table here, there's lots of different combinations here of protocol and format and streaming sort of security solutions that are available for each of those protocols. I'm not going to get into too much detail here. Just wanted to have this, present this, for your reference, really. But you can see things like Microsoft Smooth Streaming works really well with Microsoft's PlayReady DRM. Adobe has their Adobe Access product here. There's a number of third-party DRM solutions. In general, the way we think about and the way we encourage customers to think about content protection is really as a, it's a speed bump. And the size of that speed bump should really be commensurate with the value of the content that you're delivering. So, for example, something like the nightly news that becomes stale really quickly, you wouldn't want to have a DRM solution for that. But at the same time, a first-run Hollywood movie is something that you would want to have the maximum amount of protection for. So, with that overview of the components of a media streaming stack, let's get into and talk a little bit about the different AWS solutions and services that are available that can help you simplify some of that complexity and give you the flexibility to manage that media streaming stack and scale your content and delivery of that content to end users. So AWS has a well-formed ecosystem. I wanted to mention the AWS Marketplace here. It's an online store that helps you, buy and then immediately start using software and services that run on AWS. So we have a number of media partner solutions listed in the AWS Marketplace, from online video platforms to media servers such as the Cloud Media Server or the Adobe Media Server, encoding and transcoding services, and so on. The AWS platform overall is also cost-effective and scalable. So it's got the pay-as-you-go pricing model. You can scale the capacity as and when you need it, and then AWS has a global footprint with 9 regions around the world and 50+ edge locations with Amazon CloudFront, our content delivery service. And then finally, I wanted to talk a little bit about the media-specific capabilities that AWS has. So MPAA, which is the Motion Picture Association of America, they've established a set of content security best practices for securely storing, processing, and delivering your protected media. And a little over a year ago, the AWS infrastructure were deemed compliant with the applicable MPAA controls. So, there isn't a certification that's offered by the MPAA, but there is some documentation available that you can request it in terms of the security evaluation that was done. AWS has also achieved certifications such as ISO 27001, PCI DSS Level 1, and FISMA compliance. So, a lot of security best practices that are desired by media companies are already available with AWS. Let's talk about storing and managing your media assets on AWS. I wanted to mention 3 different AWS services here: Amazon S3, Amazon Glacier, and then AWS Storage Gateway. So Amazon S3 is an object store or a file-based storage for sort of infinite scalability and high durability of your content. And most of our customers store their media content on S3 and then use that S3 bucket as the origin server for a CloudFront distribution when distributing that content. S3 also works really well with our transcoding service, Amazon Elastic Transcoder, where you can store the source files and then have the and then put the transcoded files back into a different S3 bucket. Amazon Glacier is an extremely low-cost storage service that provides secure and durable storage for data archiving and backup. So with Glacier, customers can reliably store large or small amounts of data for as little as a penny per gigabyte per month. So a lot of customers using the Glacier service for archiving and backup purposes. And then finally, the AWS Storage Gateway. That this service helps connect your on-premise IT environment with the AWS cloud. So for things like remote office and small office applications, the AWS Storage Gateway enables you to upload sort of securely your media content to the AWS cloud for a cost-effective backup. It's also a great disaster recovery mechanism. So these are the three storage options that help meet most of our customers' need in terms of media storage. And when it comes to consolidating the growing library of media content and the growing file sizes that customers have. In terms of encoding, I mentioned the Amazon Elastic Transcoder. This is a media transcoding service for both video and audio content. And it's designed to be highly scalable, easy to use, and really cost-effective when transcoding media files from their source format into different versions that will play well on your smartphones, tablets, and PCs. The transcoding service has predefined presets, and we'll get a view into that when we do the demo. But that can help you create media files that will play on a wide range of devices like smartphones or tablets. So they're already predefined configurations that you can apply to your content so that the transcoding is done without you needing to figure out the formats and the bit rates that you need to choose. These presets are defined for playback on a lot of device-specific sort of presets, such as the Amazon Kindle Fire HD, the Apple iPod Touch, and so on. And then you can also create segmented files and playlists for delivery using the HLS protocol. We'll see more of this in the demo, but with Transcoder, what you do is you create a transcoding pipeline that specifies the input bucket, the Amazon S3 bucket, and an output S3 bucket. And then you create a transcoding job by specifying the input and output files. And then you can use the transcoding presets. So it's fairly straightforward to use and also straightforward to automate for, if you have a large or a growing collection of media content. I want to talk a little bit about Amazon CloudFront. So CloudFront is AWS's global content delivery network. And CloudFront supports all HTTP-based streaming protocols such as HTS, HLS, smooth streaming, and MPEG-Dash. There's also a number of streaming-specific caching optimizations that CloudFront has. So, things like range requests or fetching the file from the origin, throughput-optimized networking based on video-specific metrics, such as retransmits per megabyte or throughput, and so on. So we've really, gotten a lot of feedback from our media customers and optimized the content delivery network so that we can provide the best possible experience to viewers who are downloading and streaming video files. In terms of HLS streaming, you can use multiple AWS services, including CloudFront, and create an end-to-end workflow for HLS videos. So you can store the original video in an S3 bucket, use Elastic Transcoder to transcode it into the different HLS protocol specifications, and create the chunks and the manifests, which are stored back in the S3 bucket, and then tie all of that to a CloudFront distribution and distribute that content over HTTP or HTTPS using CloudFront. CloudFront has over 50 global edge locations today. And then what I really wanted to point out here is the smooth streaming support that CloudFront recently added. This is where you actually upload smooth formatted files into your S3 bucket, and without the need for you to run a media server, you can deliver the files to Silverlight players or smooth compatible devices. So there's a little bit more information about that here. The content is encoded at multiple bit rates, and it's stored in S3. There's one MP4 file per bitrate, and then CloudFront essentially takes care of the rest without you needing to run a Microsoft server, for example. CloudFront recognizes the smooth encoded files and then responds to specifically formatted URLs, and we'll see a demo of that when we configure CloudFront. So let's get into our demo. I will switch screens here and go to the AWS console. So I'm here in the AWS Management Console, and I've got my favorite services already listed up here in the shortcut menu. So let's start with Amazon S3. And with Amazon S3, one of the first things we're going to do is create an Amazon S3 bucket. So I'm going to call that bucket NB Webinar Demo, and then just hit create. So I ended up creating a bucket in the Oregon region for S3, and that's right here, the NB Webinar Demo. It's empty right now. I'll also create a few other buckets. So I'll create a bucket called NB Webinar HLS. So this is where I will have my HLS transcoded files. This will be the output bucket for Elastic Transcoder. So let's create that bucket. We'll also create a bucket called NB Webinar HLS thumbnails. So the Elastic Transcoder service can also create thumbnails from your video when it's doing the transcoding. And then finally creating a fourth bucket for smooth streaming, where I can upload my smooth formatted files. So we'll call that NB Webinar Smooth. So once all of these buckets are created, what we'll do is we'll go to the first bucket we created, which is the NB Webinar Demo, and in this bucket we'll go ahead and upload the file, the input file, and you can see the input file here. I've got NASA MSL launch.mp4, so it's a 34 meg file. And I can set the details here in terms of permissions and make everything public, and then start the upload of that file in this bucket. So this file is uploading. The other thing we can do is go to the smooth bucket that we created. And in this smooth bucket, again, the bucket is empty, but we can upload a number of files here. A couple of files that we're going to need are client access policy and cross-domain.xml. So we can go ahead and upload those files. And then also create, so I'm not going to upload those right now. I already have a S3 bucket that has those files. And then we can also create a folder here and call that NASA multibit. So now you can see the NASA multibit folder, and in this folder is where we can upload the actual smooth formatted video, the MP4 files in the different bit rates. So I already have buckets created. As you can see here, the Nihar Webinar HLS, which has the cross-domain.xml, the Nihar Webinar Input, which has the the MSL launch MP4 file. And then I also wanted to show the Nihar webinar smooth that already has the cross-domain XML client access policy, and then the NASA multi-bit, which has all of the different bit rates for this video in smooth format already available. So once you've uploaded your files to S3, you can go to Elastic Transcoder. And we'll need the Elastic Transcoder service for creating the HLS chunks. So the first thing you do is you create a new pipeline, and you call that pipeline demo. In terms of the input, you can say let's call that the Nihar webinar input file, where I already have the MP4 file available. And then the output bucket, where we want the output to be stored, call that Nihar webinar. And the nice thing about transcoder is, it's integrated with S3, so it shows you all of the S3 buckets that you have available. So here we'll put the Nihar webinar HLS, because we're creating the HLS fragments here. You can also create a storage, select a storage class, standard, or reduced redundancy. So we'll just go with standard here. If you remember, we created the thumbnails bucket, and then this is where I specify the thumbnails bucket, and then I can create this pipeline. So as you can see, this pipeline is created, and I can create a new job here. And creating a job for transcoding is pretty straightforward as well. So you select a pipeline first. That helps narrow the list of S3 keys, or the files that are available in that particular, in the S3 buckets that are part of that pipeline. So you can easily create a transcoding job. We'll put an output prefix here, and then output details. So this is what I was talking about in terms of the different system presets that are available. So for HLS, we can start with something like HLS 400K with a 10-second fragment duration, which is pretty standard for HLS, and then an output key of we'll just call it HLS 400K. We can also add more outputs. So since this is a multi-bitrate, sort of an adaptive bitrate streaming that we want to do here, we can create a higher bitrate HLS preset. So let's say an HLS 1 meg, another segment duration of 10, and then output key, we'll call this HLS 1M. And then let's do a third one. This would be a 2M HLS preset. Segment duration is 10 again. We'll call this HLS 2M. The other thing you want to do is you want to create a playlist before you start this job. So let's call this, I just want a fourth output. So in the playlist, let's call this master. And then you see the 3 different bit rates of the presets that we've selected, and you can include all 3 in this master so that all 3 of the chunks are referenced in this master playlist. And that's really it. You just hit create new job, and that creates the new job and starts processing those files and transcoding those files. So I already have all of those files transcoded, and I can show you back in the S3 bucket in the HLS directory or the bucket. So if you look at Nihar webinar HLS and you look at the NASA MSL launch, you see all of these .ts files in the 3 different bit rates, the 1 meg, the 400K, and the 2 megs. And then here's the master.m3u8, the manifest file that's available. And then finally, let's get to CloudFront. So we have all of the HLS fragments available now. We also have the smooth encoded files available in the smooth bucket in S3. And now we'll tie all of this together into a CloudFront distribution so that we can deliver this to our users. So with CloudFront, we'll create a web distribution for streaming content over HTTP. The origin domain name, again, CloudFront is also integrated with S3, so you really just need to type the first few characters, and it'll start narrowing down the list of S3 buckets that are available here. So let's create an S3 bucket, Nihar Webinar HLS, as the origin for this CloudFront distribution. And then you can leave all of the settings to the default setting, or you can pick lots of different configuration options that are available with CloudFront. Here, I'm not going to go through all of those, but all you really need is to configure an origin, and you can see this this distribution is now in progress. So you go to the distribution details, and you can configure a second origin. So the Nihar Webinar HLS is where we have the HLS fragments available. We'll create a new second origin that is Nihar Webinar Smooth, and that's where our smooth encoded files are available. And we'll say create. So now we have this other origin available. And then let's go to cache behaviors. So you see right now all requests will go to the default origin, which is the HLS origin, but we'd like the smooth request to go to the smooth origin. So let's create a second cache behavior that has a path pattern of NASA multi-bit /star. So any URL that matches the NASA multi-bit /star or anything after that will end up going to the smooth origin. And on this particular cache behavior, what we want to make sure is we enable smooth streaming. So we just say yes here for smooth streaming, so that CloudFront knows that any files that, or any requests that come through with a path pattern of NASA multi-bit / are requests for smooth encoded files. And that's really it. You create this particular cache behavior, and then once this distribution is done deploying, which takes a few minutes, you can actually start vending out URLs for both HLS as again, I already have a CloudFront distribution created here, so I believe this is the one where you'll see the exact same configuration. So you see the same two origin servers and then the same two cache behaviors. And if we flip back to our PowerPoint, and we'll go straight to the end here, you see I've got a couple of URLs here. The HLS multi-bitrate and the smooth streaming multi-bitrate, both the URLs are tied to a CloudFront distribution. So the files that you will be, or the video that you'll be streaming will be coming off of a CloudFront distribution. The first one, the tinyurl.com/webinar-hls, you can type that into an iOS device, whether that's your iPhone or iPad or a Mac, and you can see the video being streamed over HLS on that device. And then since I'm on a PC here, let's go to the smooth URL, which is the second one, and then we can see that this video is being delivered via smooth streaming to Microsoft Silverlight player. There's also audio, but I have my audio turned off right now, so you can't hear anything. But you can use those tiny URLs and see the video and hear the audio. It's actually a pretty cool video. All right, so that's really all I wanted to go through. I'll leave these URLs up here so you can actually try these out in whatever devices you have in front of you right now. And then at this point, we'll have a few poll questions for you that you'll see on your screen. And once you're done answering those poll questions, we'll get to Q&A.
Thank you, Nihar, for a great presentation, and thanks to the audience for your questions. As Nihar and the team review your questions, we've launched today's poll. The first question appearing on your screen now: what is the topic you would like to learn next? Please take a moment to complete this poll. Our next poll question, how effective was the presenter in communicating the content? Our last question today, how satisfied are you with today's webinar? Thank you again for completing the polls. Nihar and team, you have the floor.
Great, thank you, Anna. So yeah, we have a few minutes to answer questions, and several questions have come up. Please feel free to add more questions via the chat window. I wanted to say I've also got a couple of other folks from the CloudFront team here. I've got Matthew, who's an engineer on the team, and then Venkat, who's also a product manager on the team. So we'll be happy to answer these questions. I may be answering some of them, and Matthew and others may be answering some others. So we'll go ahead and get started. The first question says, can this technology be used to broadcast a live stream from a camera attached to a computer? So the answer there is, the technology that I demoed, which is the CloudFront's native HLS and smooth capabilities, these are really designed for on-demand video delivery. CloudFront does support live streaming as well. For live streaming, we do have documentation and tutorials. So if you just go to the CloudFront documentation page, you can look at CloudFront live streaming options and the tutorials available there that help you build a production quality streaming stack using Amazon EC2, where you're running a media server, and then using CloudFront to deliver the live stream. The big difference here is that for the on-demand streaming, the demo that I just did, you actually don't need to run a media server. You're simply using Amazon S3 to store the encoded files in the case of Smooth, and then in the case of HLS, you're also using Amazon Elastic Transcoder to transcode those files, and then just deliver them directly from Amazon CloudFront without the need for you to run a media server on EC2. Another question, does HLS work on Android? And the answer is, the short answer is yes. HLS version 2 is supported on Android 3.x, and then HLS version 3 is supported on Android 4.0 and above. So there are, some Android versions that are not compatible with HLS, but you can find a lot of resources on, on the web in terms of support for HLS on Android devices. Another question, is the CloudFront distribution for Smooth a separate HTTP distribution? Can it be used for other web workloads, such as RTMP distributions, which is only for RTMP? So, Matthew, did you want to?
Hi, this is Matthew from the CloudFront engineering team. So the answer to this question is yes. The HTTP distribution you are using and configuring to deliver Microsoft Smooth streaming encoded videos via CloudFront can be used to serve static assets and other web pages as well. We use the cache behavior and path pattern feature to signal to CloudFront that certain files and certain URLs are potentially for Smooth video requests. that you can set up multiple cache behaviors and multiple origins to serve the other assets associated with your web page, such as the player or any website Chrome.
Okay. Great. So another question, are there extra charges for HLS and Smooth? So in terms of pricing and extra charges, there are no extra charges for using the AWS resources to deliver either HLS or Smooth. The demo that I showed and all of the AWS resources, you simply pay for what you use, and the pricing for each of those services is available online on our website. So for Amazon S3, that would be the data you store, the requests you serve out of S3, and the data transfer charges, if any. For Amazon Elastic Transcoder, again, the transcoder pricing is available online as well, but it's based on the number of minutes of video encoded in HD or SD format. And then for Amazon CloudFront, again, it's the data transfer and request fees that you incur when using the service. So just the the action of selecting the smooth streaming configuration option in Amazon CloudFront does not incur any additional charges for you. Another question that came up is around geo-blocking and if we support geo-blocking. So I wanted to address that because that's a relatively new feature that CloudFront added in late 2013, so just a few months ago. But yes, we do support geo-blocking. So when you're using CloudFront to deliver your video content, you can actually configure a whitelist or a blacklist of geolocations, which are a list, which is a list of countries currently, and and then once you configure that, CloudFront will then, the edge servers will then apply that configuration to all your viewer requests. So if you've configured a blacklist, then if we see a viewer request coming from one of those countries, we will block that request and not deliver your content to that viewer. Same thing with a whitelist. If you configure a whitelist, then we'll serve the request only when a viewer is requesting from that whitelisted country, and then block everyone else. So yes, this functionality is available, and you can go to the AWS Management Console and create a CloudFront distribution, or if you have an existing distribution, you can just go to the Restrictions tab, and then you'll be able to configure geo-blocking there. So if you have other questions, please feel free to input them into the chat window. We're just looking through the questions as they're coming in and answering what we can right now. If we're not able to answer some of the questions right now, we'll be happy to follow up with you after the webinar. There's another question that came up. Can CloudFront do on-the-fly chunking for HLS? So the short answer there is no. But the way you can, for on-the-fly chunking of HLS, the way you can do that is by configuring a media server in front of Cloud, or behind CloudFront rather. So, when a viewer request comes into CloudFront, CloudFront can send that request over to the media server that can do the on-the-fly chunking. The other option is what I demoed, where you can actually do the chunking in advance using the Amazon Elastic Transcoder service, and then save those chunks into an S3 bucket, and then configure that bucket as the origin for your CloudFront distribution. So in that scenario, when a viewer request comes, CloudFront will simply go to the S3 bucket, retrieve the chunks from that S3 bucket, and then deliver those to the viewer.